Okay, so the system for discussion this afternoon is an automatic changeover switch. I'm not sure if I need to actually maybe discuss what an automatic changeover, but let me just run through some stories. There's hardly any house in Nigeria that uses generator that does not have a manual changeover switch. Abi? Are you there? Faculty, can you hear me? Yes, sir. Okay. So I'm saying that an average house has automatic changeover switch. I mean, they have the manual changeover switch. What the manual changeover switch does, simple is this: you have a two inputs, up and down, and then you have an input on, you have another point on the middle. So depending on, I mean, what location you want to place your NEPA generator, the system or that box is called the knife edge. What it does is it allows you to feed in NEPA as a source and feed in your generator as another source, and such that on the middle you can then source or get light into the house or wherever you want to feed. Now, so the way the manual changeover switch works is this: wherever you want light, or whichever of the light sources you want to use, whether generator or NEPA, what you do is you go to the knife edge and then you turn the knife edge to that position. If you want it in your generator, you turn it to your generator position. If you have placed it up or down. If you want a NEPA, you turn the knife edge to the NEPA position and then you have NEPA lights. That is how the manual changeover switch works. In the process of using a manual changeover switch, part of the responsibility that accompanies it is that you will have to go to your generator to go turn on your generator and turn off your generator. Now, for some persons, maybe because of the noise of their generator, the noise their generator makes, or the distance from where their generator is to the house, they might not know when NEPA has brought light or when PHCN has installed lights. So for some people, they have this bulb indicator that they need to continually look at, they need to continually monitor to tell whether there's NEPA light or there's generator light, or when PHCN light has been restored. That's for some persons. For some other persons, they have buzzers. They have buzzer in the house. So when NEPA light comes in while they are running on generator, there's this buzz sound they get. Bah! Sometimes maybe not by them, maybe by their neighbors. And that's where they know that, oh, PHCN has been restored. So if you look at it, the process to having a manual changeover switch requires that you have a means to verify, or an indicator to tell when PHCN is available. That's one. Two, you'll have to turn on your generator. You will also have to turn on the knife edge to the position of the generator. You have to do that. Now, all of those processes are what this system is now solving for you. That is all that this system is solving for you. So what this system is doing is that instead of having an indicator, maybe a buzzer or a virtual indicator to tell whenever is available, when PHCN is restored or not, this system is all you need to tell if PHCN has been restored or not. But how does this work? Different from the manual changeover switch that makes it an automatic one. How does it work? Let me explain quickly. Just the way your manual changeover switch requires inputs from PHCN and from your generator, this box too requires such inputs. The first two inputs here, if you count from bottom up, are you there? From bottom up, this first input is where your NEPA comes into place. This is where you input your NEPA. The first two inputs, live, neutral, from bottom up. Hope you are with me. Okay, so this is your life from the bottom. The first O from the bottom is your life. For hello. Can you hear me?
Yes, sir.
Okay, but you are changing location. You are changing location. What's happening?
I'm looking for network. It's skipping over.
Okay, I'm looking for network.
It's skipping. Yes, it's skipping.
Okay. Should I give you a few minutes to look for a good location to get network? Or should I continue?
It's continue.
I just continue. Okay. So I'm saying that from the bottom up, yes, the first O is where your NEPA life comes into. Now, the next O, which is the second O, is where your NEPA neutral come into. The NEPA neutral. The third one is where the life of your generator come into. The fourth one is where the neutral of your generator come into. Then the last two up is your life and neutral too. But this place is where you source light into the environment, light into the house. Either the source from NEPA or the source from generator. This is where that comes into. So this is like the middleman. This is like the common. This is where your house utility is sourced from into the house. Don't forget this the routine. Life neutral, life neutral, life neutral. Life neutral, life neutral, life neutral. The first life neutral is your NEPA or your PHCN. The next life neutral, which is the one in the middle, the life neutral is your generator. While the next life neutral, which is the last one, the uppermost last one, that is actually where you take light into the house. In front here, the system has two light emitting diodes. If you look in the box inside, you're going to see two LEDs inside this at these 2 points. I'm not sure if the lights, I think it's reflecting into it. Aha, you can see the holes. You can see these 2 points. These 2 points. This and this and this. These 2 points. There are light emitting diodes there. Are you with me? Now, the first one, the first one, this is the one that indicates that your NEPA light, that's which means NEPA or PHCN is being fed into the system. This is one that shows that. This shows that PHCN has been fed into the system.
Yes, sir.
Okay, so let me quickly run through what I said before, and then we just take it from there. I said that our explanation is actually based, or this class is based on explaining the automatic changeover switch. And I said there's what I was trying to say before was to distinguish between the manual changeover switch and the automatic changeover switch. And what I said was that for the manual changeover switch, I mean, like the one you have a common used in the house, they are the knife edge. If you look at the knife edge has 3 different inputs: one up, one down, and then maybe another one on the side. Now, I'm hearing myself. I don't know, where am I hearing myself? Chris, can you mute your mic? Almost okay. All right. No, don't worry. I'm fine.
Okay, sir.
Okay. So I said that the manual changeover switch just has 3 inputs. Those inputs are NEPA life and neutral, generator life and neutral, and then the house life and neutral. Those are the 3 inputs. Now I said that, and I said, I mean, just the way it is on the manual changeover switch, you have it on this automatic changeover switch too. Where from the bottom up is your life neutral for your mains, which is NEPA, life neutral, which is the one in the middle for your generator, and then life neutral, the one that feeds the house. So these inputs, or these inputs and outputs, are very consistent with what is in the manual changeover switch. Very consistent. And that's an answer is this. I said, for you to actually operate your manual changeover switch, what you will need is that you'll have to go and turn on your generator and then switch to your generator inputs. But in the case of using the automatic changeover switch, of course, you'll have to go and turn on your generator, but you do not need to come and switch anything here. This system will recognize the presence of your generator and automatically place the house on that generator input. That's what it does. Now, on your manual changeover switch, when PHCN or NEPA is restored, there are a few things that will happen. You either have an indicator, a bulb to tell you that NEPA is not available. What it means is that you have to be monitoring that bulb. You have to be looking at that bulb. For some people, what they have is a buzzer. They have something like an alarm that goes off whenever NEPA is available. Now, you can have one, or you can always listen to that of your neighbor or the one on your streets to tell that NEPA is available. Those are the two options. But on the automatic changeover switch, you do not have to be going looking at it, whether it's then NEPA. No, you don't have to do that. The moment you are running on generator and then PHCN brings light or the utility is restored, this system automatically recognizes that NEPA is now available and it will do a few things. First, it has an indicator. You see this, there are two light emitting diodes here. One of the LEDs, this one here, the one here is the one that shows that NEPA is on. So if you are, yes, this is one that shows that NEPA is running. This one. This other one shows that generator is what is running. So if you were formerly on generator and the generator was turned on, this light emitting diode here, or this bulb here, this indicator here will come on. So that if you are looking at the automatic changeover, so you can actually see lights coming here as an indicator to show that you're actually on generator. Now, when NEPA restores lights, what actually you should, or what will happen is that this indicator will come on. This indicator is what tells that, oh, NEPA is now available. This one indicator. Now, apart from having an indicator to show that NEPA is now available, are you there, faculty? Faculty? Hello? Okay, let me continue. Maybe we'll just be able to share the video with you. Okay, so the moment NEPA comes on, or the moment PHCN is restored, what happens is that this indicator comes on. This system recognizing that PHCN has been restored, it has a buzzer in it that puts up an alarm. That alarm comes on for 10 seconds. 10 seconds. Within that 10 seconds, this system does not switch your house to NEPA light yet. It still keeps you on your generator for a few reasons. Part of the reasons is why it is giving you that 10 seconds alarm. It is also holding the voltage down to make sure that the voltage is steady. The voltage is normal before it transfers your load to that voltage. Usually when NEPA light comes in, it comes in with some inrush. It's what we call, it comes in with just both with sometimes it fluctuates, some other time it is a bit high until load begins to be on it before the voltage stabilizes. So that voltage inrush sometimes can damage your electronics if it goes into your electronics directly. So what this system does, what this box does, is that it helps you hold that voltage down for 10 seconds while giving you an audible indicator or an audible alert or alarm or notification of NEPA's presence. After that 10 seconds, what the system does next is that it automatically switches you or the house to the NEPA lights. While you're on the NEPA light, it automatically turns off your generator. That is what this box does. Now, let me take it quickly again. I'm saying that the inrush that comes with NEPA lights comes in with some surge, what they call electrical surge or voltage surge. That voltage surge is enough to damage your appliances. Enough to damage your appliances. So what you do, or what the system does, is that it helps you hold that surge. It helps you hold the voltage enough for the surge to have done what? Settle down. For the voltage to have now normalized. That is when the system can then transfer your house, your appliances to the NEPA voltage. The alarm goes off after 10 seconds. And then it can then shut down your generator automatically. You do not need to go to your generator, you just shut down your generator. That's what system does. Now, the question you'll be asking is, how does it shut down my generator? How is this system going to turn off my generator? If we have discussed that the only wire that goes in here are just all utility wires, NEPA wires, NEPA input wire, generator input wire, and the house wire here, the one that sources voltage to the house here. But we also have this other connector. This is where your generator shutdown is connected to. Excuse me. The question really was, how do I connect this? Of course, what you just need to do is to get a flexible wire. That's all you need. Get a flexible wire that is long enough to connect to this place, to these two ports, and then to the place where your generator is connected to. That's all it needs to. That's as far as the wire needs to get. When the wire gets to where your generator is, what you do is connect the wire to your generator on and off switch, such that the manual responsibility of that switch can be carried out by the relay connected to this point where this wire is sourced into the generator switch.
I can't see you anymore, sir.
Hello?
I can't see you anymore.
You can't see me anymore?
Yes, sir. It's blank.
It's blank.
Yes, sir.
But I can see myself. Can Chris see me? If Chris can see me, let him know. So Chris can see me, so why can't you see me?
I'm only seeing myself. I think it's the network. Oh.
It's your network.
Okay, I'm not seeing you, sir. I'm seeing you.
Okay. So I'm saying that what you need to do is that you need to get a wire, a flexible wire that goes from here. That flexible wire goes from here and goes to the switch that is on your generator. Your phone is connected to the switch, to the two ends of the switch. On that switch, what you actually find there is just one of the wires that comes from the engine or from the spark plug or the ignition coil, and then one other one from the metal part of your generator. When you bridge those two wires, what happens is that the generator automatically shuts down. So whenever you flip that switch to the off state or to the off position, that is what that switch does to your generator. That's why your generator goes off while it is running when you turn that switch. That part is where you connect wire from here to. So that the moment this system senses the presence of PHCN, what it does is hold the voltage for 10 seconds, gives you an audible indicator for that 10 seconds, enough for the surge that comes from with the voltage to have settled so that the voltage is now normal for your appliances to use. That is when afterward it transfers the house to the utility voltage that has been then be supplied, and then it goes and shut down your generator through these 2 points, bridging the wires that comes from your generator shutdown wire or shutdown switch to this point, it then turn off your generator, and that's how the system works. Now, there's also the case of what if you've been running on generator and NEPA has not supplied you voltage and you want to turn off your generator. Instead of going out to where your generator is to turn off your generator, simple. You can simply hit this button. There is a button underneath this system that comes with it. If you press this button down long enough, for between 2 to 5 seconds to 10 seconds, it will turn off your generator set for you.
Okay, sir.
Because this switch is directly connected to this output, to this connector point that goes into your generator on-off switch. So if you get wire from the generator on-off switch and connect to this place, when you press down this switch or you depress this switch, when you press the switch, what happens is that this switch carries out the same function as though you have gone to the generator set and then you have flipped the on-off switch to the what? To the off state. So that's what it does. So in a nutshell, what this system actually does, first is that it's a 30 amp system. 30 amps means that you can actually use load on NEPA that does not exceed 30 amps. It's the capacity of this man. 30 amps or 30 times 240 volts should be around 7.2 volt amp or 7,200 watts or 7.2 kilowatts or 7.2 kVA. is the maximum capacity on NEPA that you can use on this system. For generator, you can use a generator as high as a 40 amps generator. Power for that one will be 40 times 240 volts. That is a bit still higher than the 7.2 kVA. That is the capacity of this box. It's small, it's compact, but that is as powerful as it can be. It is efficient. It has an on-off switch here that needs to be put on if you want the system to do its automatic work. If you flip this switch on the off to the off state, what happens is that this system perpetually places your utility on generator. It means that once you on your generator and you turn on the circuit breaker or turn off the circuit breaker, you will have light here in the house. But when NEPA comes, the system will not function with light. It will completely ignore the NEPA presence. What it means is that if NEPA comes on, it will not buzz. It will not actually even show NEPA indicator here. It will not. It will be perpetually kept on generator. Flipping this switch to the off state is as good as returning your manual knife edge to the generator point. If you want this system to continually monitor for both the presence of NEPA and generator, and then prioritize NEPA whenever you're running on generator, such that it can switch off your generator and return your load or the house to NEPA, you will have to flip this switch to the on state. On the on state is where this system can function appropriately. On the on state is where this system can do its automatic work. If you flip this switch off, it will not respond to NEPA input anymore or PHCN input anymore. It will not even alert you. It will not even tell you that PHCN is being restored. It will not. It will not. This system will only work on generator and generator only if this switch is flipped to the off state. When you put it on the on state, that is when it can carry out its automatic work or functionalities or functions where it senses both NEPA and generator presence and then determine which one it impresses on the house. And like we have discussed, NEPA is prioritized. It means that whenever NEPA is available, irrespective of the voltage, this system will switch you from generator to NEPA voltage. Now, this system now has another property that we should mention, that is worth mentioning. It has an overvoltage and under voltage protection. I'll say it again. It has an overvoltage and an under voltage protection. What it means is this: when voltage comes too high, way too high, above 240 volts, what happens is that the transformer inside this system goes off. When that transformer goes off, of course, the primary coil of the transformer will burn off. And when its primary side of the transformer burns off, knowing that transformer primary and secondary are isolated, they are not directly connected, voltage is only induced from the primary to the secondary. What will happen is that the secondary part of the transformer and the rest of the board will be protected, such that when the light is normalized, you are not going to have light anyway from NEPA because the system will not work except you run generator until you go to change the transformer inside. So the transformer that is inside is what we have actually used as the overvoltage protector in this system. Also, when the voltage is low enough that it cannot impress a 12 volt at the primary coil of the transformer if the transformer is induced from the primary side, what happens is that this system is not going to come on. And if it does not come on, your house and your plants are protected from what? Under voltage. So it's safe to say that this system has an overvoltage and under voltage protection. For the under voltage protection, it helps against low voltage. For the over voltage protection, it helps against what? High voltages. It does that for you. So that is just that about the system. If we are not actually going to be saying too much story. We are saying that it's a 30 amp system on NEPA, 40 amp system on generator side. Don't forget that. It has an automatic shutdown, and this is where you tap the automatic shutdown. You can also have your own manual shutdown without going to the generator set by pressing this button down. Of course, you can also go to the generator set to actually do the shutdown. But don't forget that if this system is to work optimally for you, you will have to connect NEPA input here, generator input here, and your house is going to be connected on the top part. You also have to connect your generator switch, get 2 wires from generator switch to this place. That is when the system can then work effectively. Don't forget, NEPA is prioritized. At the sense or monitoring or presence of NEPA, this system would give you a 10-second audible indicator, and then the NEPA indicator will come on to let you know that NEPA is now available. After 10 seconds of holding the voltage, such that the surge that comes with the voltage is held down for 10 seconds, the voltage of course will have returned to normal. That is when the system can then transfer the house to generate to the NEPA input and then shut down your generator for you automatically. That is what this system offers. It is our own automatic changeover switch from OpstepE Engineering Limited. Hope it's clear.
Yeah.
Okay. So let's get your questions.
If the generator set is on and they bring the lights, changeover will change it, right?
And shut down your generator.
Now, if they don't take up the lights, please change back.
No, it does not. This system does not have the capacity to turn on your generator. It doesn't turn on your generator. You will have to turn on your generator yourself. The only thing the system does is help you shut down your generator. It doesn't turn it on. And one of the reasons why we don't do that, or why this particular model does not have that, first, we're also trying to actually reduce litigations, and I'll tell you why. There are clients who don't take their time to check the oil level of their generator. Now, if your oil level of the generator is low, your generator does not have oil, and generator is running. For some generators, they can actually shut down. For some, it damages the engine. So we leave it in the purview or in the responsibility of the clients to go check their fuel level, check the oil level, and then turn on their generator themselves. Are you with me? So that you are liable, in the case of a damage to your generator. The only thing this system does for you is turn off your generator. One other question that I will expect that you are going to ask is this. For the generator to run effectively, the fuel valve needs to be on. If the fuel valve is on and then your generator is turned off, what happens to the fuel? Won't my generator overflow? No. Generator does not overflow if your generator, except your generator is faulty. Because if the engine is turned off, the chamber that requires or that requests for fuel will not request for fuel anymore. And if it does not request for fuel, then there can't be fuel flow. And if there's no fuel flow, then petrol, or of course, petrol will not be leaving your petrol tank into the engine, because the engine that is supposed to use it is full.